Welcome to our metallic bonds lab. So we have 8 different samples here, and I'll be showing you the periodic table and where they're kind of located. But if you have yours in your notebook, go ahead and open it up. All right, we're going to look at different properties of metallic bonds. Remember, we talked about how metallic bonds have those mobile valence electrons, that C of electrons model. And so they give those metals different kinds of properties. So we're going to look at those, and we're going to look at some that aren't metals as well. And so we're going to test them. Remember, you've got your 3 properties of your metallic bonds. You've got your ductility or ductile, which means we can turn it into a wire. We can stretch it out without breaking it. The other thing we have is conductivity. We're going to use our conductivity meter to see if it conducts electricity. And then it should be luster. It's very nice. It's usually shiny. What's that last one? And then we have malleability, which means we can flatten it into a flat sheet. So we're going to look at that. We're going to have a couple tools here. And then at the end, after we finish that, we're going to look at also reactivity, okay? And depending on the year, you may have reactivity in your lab sheet and you may not, okay? So make sure you look at that. So the first thing you're going to do, though, is you're going to go to Google Classroom and either print out or start filling out your electronic lab sheet while we're doing this. So go look and get Investigate Metallic Bonds. So the metallic bonds lab sheet looks like this in the front. All right, so let's go ahead and get started. I'm going to go ahead and point that camera down so you guys can see what's going on down below, because you don't want to look at me. You want to look at the metallic bonds. So let's go ahead and point our camera down. This is where we're going to kind of work. We'll see how that works on the camera. Change it back to the black if we need to, okay? But the first one we're going to look at is aluminum, okay? And so here is aluminum. It's kind of hard to see, huh? Okay, so there's aluminum. I'm going to bring you guys down a little bit farther just so that you guys there in virtual world can see what I'm looking at, okay? All right, so this is aluminum. I'm going to hold it up here to the camera. This is aluminum. As you can see, it's a solid, but I want you to notice what color is it. It's kind of a silverish color. As far as luster, it's kind of shiny. It's a little bit dull. And some other properties. Well, it's hard, okay? And it's silver. It's stuck to itself. Its shape is kind of odd shaped, right? And then we're going to take a look at a couple of things. So the first thing we're going to do is we're going to do the tapping. So what does the tapping tell us? Notice this is not in a wire and it's not really flat. But can you do that to aluminum? Can we make it flat? So think about that. Those are physical properties of aluminum as well. What are your soda cans made of? So I'm going to go ahead and I'm going to look at tapping. So I'm just going to tap it. Does it break? And this tells me malleability. So notice as I go through, it's not shattering. It's not breaking. It's just making a hole. So this definitely is very malleable. And that's why we can have aluminum cans. So let's look at the periodic table. So we're going to look at periodic table. Where is aluminum on my periodic table? Okay, so I'm going to turn this around so you guys can see it, not me, right? So we have aluminum right here. That's where our aluminum sits. And it says it's a P. And if I read the P, it's a post-transition metal. So that's good because it is malleable. We can hammer it into a thin sheet. It may start out this way. Has a little bit of luster, which metals should have. And the other thing we want to see, does it have conductivity? So let's go ahead and test it. And as you can see, my red light has lit up. Aluminum does conduct electricity. So you will put that in there, does conduct electricity. So that is aluminum. The next one we're going to look at is carbon. And carbon actually is charcoal. So that stuff you put in your barbecue, if you have a charcoal barbecue, is pure carbon. Okay. So let's see what it does. First of all, I forgot to do it at the beginning, but let's do it at the beginning. We're going to see where carbon sits on our periodic table. It is here, and it's an N, and it's a non-metal. So if it's a non-metal, does it have mobile valence electrons? It's not a metal on metal. And what should we see? Should we be able to do this? So it's a non-metal. So there's my carbon. And it's actually, I'm going to put it, let's see, I'll put it on this white piece of paper. Okay. And let's see if it's malleable, which means when I hit it with a nail, it should not be brittle. It should not break apart. Let's see what happens if it's a metallic bond. And again, as soon as I end up tapping, it breaks it apart. Okay. So result of tapping, it's brittle. Other physical properties, it's very dusty. It's got dust everywhere. It's not very lustrous. It's kind of a dull black color. Okay. And then let's see about conductivity. Does it conduct electricity? See if I can get my conductivity meter in there so you guys can see it. Got to move it the right way, Miss V. It does conduct electricity, but notice it may conduct electricity, but did it have all the other properties? Was it lustrous? Was it malleable? Do you think we could turn carbon into a wire? Okay. All right, next one we're going to look at is copper. This one is, again, I'm going to clean off my paper so I don't have contamination in case I need it, is again, copper. See, is it a metal? So, copper is in here. As soon as Miss Z finds it, there it is, number 29. And it is a transition metal. So we should see all those properties of a metal. It should be malleable. We shouldn't see it break apart when I tap it. It should be lustrous. And here's our copper. It is very shiny, as you can see. Okay. It's kind of like I don't know how to explain it because we always say it's copper color. Kind of like a bright, kind of yellowish orange. Okay. All right, and it's already in a flat sheet. Can I take it into a flat sheet, right? So let me get my hammer and my nail, and let's see if I tap on it, will it just break? Let's see what happens. And again, nope. It is not breaking apart. It is not brittle. It has malleability, okay? And it would also be very ductile, okay? The last thing we want to do, does it conduct electricity? All right, let's use our conductivity meter. And once again, we see that our light goes on. It does conduct electricity. Okay. All right, our next one we're going to look at is iodine. Where's iodine on the periodic table? Iodine is here. It is a non-metal. It's in the halogen group. Okay. All right, so let's look what iodine looks like. Iodine, I am not going to touch with my hands. If you guys have ever seen it, it does stain your hands. So I'm going to pick this one up, and it's already staining my tray. It does come as a solid. Okay, and so we're going to get a piece of iodine. So there's iodine. It actually is kind of shiny. It's kind of sparkly a little bit. I don't know if you guys can see that there. It's dark gray, and it's just an odd shape. It is a solid. So the first thing we want to say is color. It's our dark gray. Luster. It sparkles, but yet it's also dull. So I would say no. Other physical properties is it is a solid. Notice it's already turning my paper yellow. So it leaks. Let's see what the result of tapping is. Is it brittle or not brittle? And there it goes, breaks up, and so it definitely is brittle. Does it conduct electricity? So we're going to try to get that on there. Do I have my lights in? And no light. It does not conduct electricity. So this is iodine. Okay, put that back in my tray. Okay, the next one you're going to look at is magnesium. Magnesium sits here, okay? It is in group 2. It's with my alkali earth metals. It is a metal, magnesium. So we should see all the properties of a metal. So let's see. Here's my magnesium, okay? It is got some luster to it, some shine, okay? It is kind of like a light gray, okay? Other physical properties is I can bend it, actually, okay? It's in a ribbon. It's flat, okay? And I'm going to go ahead, and the next thing I want to do is result of tapping. Let's see what happens. Is it brittle or not? And once again, it's stuck to there. It is not breaking apart. It is not brittle, so it is definitely malleable. And conductivity. Let's see what it does. Does it conduct electricity? Woo! And it does conduct electricity, so that is a yes. And that is magnesium. Okay, the next one we're going to look at is silicone. And this is what silicone looks like naturally. You guys probably don't see it very often. Okay, it is a solid. Sorry, it is here. It is in group 14, number 14. And silicone, it says it's an M, which means it's the metalloids. Now we're into those semi-metals. So it's halfway between a metal and a non-metal. So this is, get you a new paper so we don't do that. Okay, so this is silicone, okay? It is very shiny and lustrous, which is a property of metals, of course, okay? It is a solid. I'm going to put it here, okay? Other physical properties is it's like, I don't know, it's very shiny, okay? But it's very thin, okay? All right, so the next thing is result of tapping. Is it malleable? So I'm going to put a nail on there, give it a little tap, and it broke apart in many, many different pieces. So it is brittle. So it doesn't have, because it's a metalloid, it doesn't have that property of metals. And the last one is conductivity. So we'll move it. And again, it does conduct electricity. So notice it has some of it, some of the properties of metals, but not all of them. Again, that is silicone. Okay. Next one we're going to look at is going to be sulfur. So sulfur is here. Okay. Sulfur is yellow. It's a flat sheet. It is definitely not shiny. And we'll see, where is sulfur here? It is here in group 16, number 16. It is a non-metal. So since it's a non-metal, we should see not all the properties of a metal. So I'm just going to grab, you don't want to touch sulfur, one piece of a sulfur. There it is. Okay. It's really hard to see though, huh? Let me put it on the black and see. There you guys go. Now that's a little easier to see. Okay. So it's yellow. It's definitely not shiny. There is no luster. It's kind of dull. Looks a little dusty. Okay. Result of tapping. And again, it broke completely apart, okay? And then the last one we want to do, and I don't know if I'll be able to do this, tiny little pieces, okay, is conductivity. So let's get our conductivity meter in here. Don't really want to touch sulfur. And we'll put it on there. And again, no light, so it does not conduct electricity. And it shouldn't, it is a non-metal, okay? All right, I'm going to clean this one up. Ooh, there we go. Okay. And our last one we're going to talk about is going to be zinc. So zinc is a flat sheet here. It is very shiny. It's very lustrous. Again, it's like tin, or it's like a gray kind of color. Okay. All right, so last thing is result of tapping. Is it malleable or is it brittle? And again, Not brittle, doesn't even go out. That's why we can have it in a flat sheet. So, and the last one is conductivity. And it does conduct metal. It does conduct electricity. For sure, it does conduct electricity there. And so, of course, zinc, as soon as I find it on here, is here, number 30. It is a transition metal, so it should have all those properties of a metal. Okay? All right. That is all of our data. So your data table should be complete. If not, go back and do that. Okay? The next thing I want you to do is I want you to look. If you have the reactivity column on your lab sheet, then you want to stick around for a little bit longer because I'm going to do reactivity to fill that one out. Sorry. The last thing you're going to do, though, if you do not have reactivity on there, is you're going to go fill out your last question. So you're going to talk about review the data gathered for the 8 elements. Sort the 8 elements into groups based on their similarities. So you're going to put who goes with who. So hopefully you should see that you have metals and you have nonmetals, right? And you might have some in the middle as well with our metalloid. Are there any inconsistencies within the group, such as do some of them conduct electricity and some of them don't? Are some of them malleable, they didn't split up, or they did? Are brittle or not brittle? Okay. And then the last one, the third one here says, look at the location of the periodic table of each of the 8 elements tested in the lab, which I just showed you. How do the properties of these elements compare to the general position on the periodic table? How do they compare? How are they to each other based on your group? So if you put like some of our non-metals together, right? So we had sulfur and we had carbon. Where are they? Are they close to each other? Remember, we have the staircase. Okay, remember where they're at. And then the last one is predict the physical and chemical properties of following elements based on this lab. So as you looked at these 8, you're going to look at selenium, calcium, and cobalt. So based on the other ones, and those are all in here. So if you look at cobalt, okay, it is right here. It is number 27. Okay, and you have selenium, which is number 34, which is right there in the column with sulfur. And then you have calcium, which is over with magnesium. So based on what you saw with magnesium, what you saw with sulfur, what you saw with magnesium should be pretty close to what you should see with calcium. So what should the properties of calcium be? And selenium should be really close to sulfur. So what did you see with sulfur? So what would the properties of selenium be? And then the last one is cobalt. So you saw copper and you saw zinc, and cobalt is just to the left of those two. So based on those two, what are the properties that you should see with cobalt? Okay. All right. If you have the lab with no reactivity, that is the end. Go answer your 4 questions. If you do have the lab with reactivity, stick around. All right, welcome back. So those of you that have the reactivity, we're going to look at that really quick. So what I've done, we're going to look down here, is I've placed each of our 8 samples in a test tube. And the first thing we're going to check is we're going to see reactivity with hydrochloric acid. And once you see the different reactivities, what I want you to do is I want you to think about that trend of reactivity on the periodic table. All right, so this is going to be with hydrochloric acid. And we just need a few drops of each one. So this is going to be, I think I'll start at the top here. We're going to do aluminum. And chemical reactions means that there's bubbles, okay? And so this one with hydrochloric acid, there really isn't any reactivity with aluminum. This one is going to be with carbon. I'm not seeing any reactivity with carbon. No bubbles. This is with copper. And I'm not seeing anything with copper really. This is iodine. Okay, nothing really. Iodine, the only thing I'm seeing is a change in color. I am seeing a change in color. It's becoming kind of yellowish. Magnesium. That, I don't know if you guys can hear it. It is bubbling like crazy. There definitely is a reaction with magnesium with hydrochloric acid. Okay, and you can probably see that starting to just bubble. It's really starting to foam up now. How about with silicone? I'm seeing zero reaction with silicone. Magnesium is almost gone. You can see all those bubbles, okay? How about with sulfur? Sulfur, I'm not seeing any reaction. And our last one to test will be zinc. And I'm not seeing any reaction with zinc very much at all either, okay? All right, so go ahead and record those in your data, and then I'm gonna clean these up. And actually, I wanna show you, I thought iodine, yeah, it's starting to turn really yellow, okay? And actually, I see some yellow, so you can see some yellow there as well. All right, I'm going to clean these up, and then we're going to do our reactions with our copper chloride, okay? Welcome back. So we have all of our stuff back in here, and now what I'm going to do is I'm going to do the ones with copper chloride, okay? All right, here we go. And copper chloride has copper and chlorine with it, so it's an ionic. Does it have a reaction? So the first one we're going to do is, I'm going to start with aluminum. Woo. Okay. And there's aluminum. Not really seeing anything happen. The next one we'll see is carbon. Not seeing anything happen with carbon. Next one is copper. Not really seeing any bubbles with copper. Iodine is our next one. Not really even seeing anything with iodine. Magnesium is our next one, and that's the one that reacted with our hydrochloric acid. But again, now there is bubbles in that one. I don't know if you can hear it. Let's see. But there is definitely bubbles in that one, so there's definitely a reaction with magnesium. Sorry, I'm going to go back and actually listen to the rest of them. Nope, no bubbles yet. Nope, just ringing. It's knocking around there. There is a reaction with aluminum. Now we can see this reaction. I thought there would be reaction with aluminum. Aluminum is actually turning like a dark brown, and it has bubbles. I don't know if you can hear it. Aluminum is reacting with copper chloride. Okay. Next one we're going to check is silicone. And this one is not having any reaction. And then we have sulfur. And not much is happening with sulfur either. I'll go back and check those three. And our last one is zinc. And almost immediately when I added the copper chloride, the zinc turned like a dark black. Okay, there is nothing else, but zinc definitely had a reaction and it turned like a dark black. Okay, I don't know if you guys can see that in there, but it's a black. So that definitely had a reaction. All right, so if you had reactivity on your sheet, I want you to go in and make sure you filled all those out. Okay, and then go and answer your questions. Okay, and if you have any questions or anything, please let me know. All right. I'll see you later. Bye.